All right, welcome everybody. So thank you for joining in. A little bit different live stream than I was planning on doing, but my technology was not working. I'm not sure what's going on, and I got back in town today and did not have really time to set up my live stream. I'm actually in a new kind of studio environment, so I'm not like don't have everything set up the way I really would like it to be. And of course, I'm trying to go live tonight for my first weekly stream, and I cannot get my green screen and everything else to go up. So, regardless, though, I was like, you know what? I said I was going to go live, and so that is exactly what I am going to do. So, I do apologize. It's not as clean as I would like, but hopefully, my mic is still working out, and that is at least giving you guys some decent audio. And then I have some problems to kind of go over as well for the first live stream. So you guys are just going to get this little side look for me. So the first one is just going to be kind of talking about mean, median, and range. Actually, I'll also just kind of go over mode as well. I'm going to do a y equals ln of x natural logarithm overview. I'm not really sure what that means, but I'm going to try to do my best to try to cover as many bases as I can. Just on a kind of a general idea for natural logarithms. Okay. And then we're going to get into just kind of solving right triangles. I don't have a calculator, so I'm not going to use. I'm not going to do like actually find the exact values, but I'll just kind of give you some ideas on what we can use, how we use different solving techniques for solving right triangles. Then we'll do a graphing a trigonometric function. So this one has a lot of transformations. And so we'll just kind of go through how that impacts the graph as well as how to sketch maybe like an initial period. Then we'll do that same thing for logarithms. And then I'm going to end with literal equations on that regard as well. So we'll just kind of practice how to solve for a literal equation. And I guess maybe what I'll do in this one is solve, oops. Let's see. No. Solve for y. And this one, let's go ahead and solve for p. So I do apologize, guys. I'm kind of a little flustered as far as not everything is working, and I'm kind of annoyed. So I'm just going to go ahead and handle these. I'm sure there's some of you that are adding to the chat, and if I do have time, I will try to do my best to get that over for you guys, but I'm just not sure what I'm going to be able to meet. Like I said, we are back actually in my school. We are back at school tomorrow. So I have to make sure I start getting everything prepared and get that all set for you guys. And I don't know why. Oh, this is very annoying. I got everything started going at like earlier than I usually do for my stream too. I was getting everything prepped in my studio for like an extra 30 minutes, and then for some reason I just cannot get my camera to all set. So I'm not sure what's going on. My camera wasn't working and my tablet was not working, and just nothing is going well. So but it looks like we do have a good stream connection, and at least we have a mic going in and stuff like that. So all right, so I do want to say hello to some of you guys before I go ahead and get in, because I do appreciate you guys joining me on my first stream of 2020. So hello Neptune, Arav, Randy, Diego, Baden. Good to see all of you. Hi Larissa. I don't. This is all makes me. Hi Rusate. From me, Peachy McLogan. I do not know what you are asking, but you gave me a super chat, so now I have to translate that and understand what it is you're doing, because I do appreciate for the super chat, and so sorry about that. Now it's going to take me a little bit of time just to make sure that I am giving that for you, because I unfortunately do not understand what you are typing in there. So all right, Randy, no, you cannot. You'll miss out. You're not the teacher. Oh, okay. I'm not sure what was going on there, but let's see what we got here. Okay, excuse me, guys. Let's go and get this through. Then we'll get to the math. Oh, Peach says, I also teach pre-calculus in Acapulco, Mexico. Oh, well, that's very awesome. I believe it's maybe Pinche. McLogan, that's, or at least that's what you're saying to me. Pinche McLogan. I'm not sure if there's a screen or not, obviously. But that's very awesome. That's very, very cool. And I appreciate this super chat. Thank you so much. And no, you cannot go to the bathroom, Diego. So, all right, guys. Let's go ahead and get into some of these problems. And then what I'll do is I will get on to you guys. So I really wish this week one would go off of a better chat. You know, it's like the first live stream of the new year. You want everything to be going good. And basically, this is my first live stream where I'm not even able to use my live stream or be able to use my green screen. Everything is like not working out. But either way, guys, we are going to make this work. Let's go ahead and get started. And then I'll hop back into the chat for those of you guys that are still with me. And if there's maybe some additional questions I can answer at that point in time, I'll be more than happy to do so. And now my computer is not going back to that. Okay, all right, so the first one is, how do you identify the mean, median, and range as well as mode? Well, mean, median, mode are ways that we measure central tendency of a data set of numbers. So in this case, we have 5, 7, 1, 4, 4, 2, and 10. So basically, just when we want to understand a data set, the mean, median, range, the central tendency is just kind of like understanding, some ways for us to really understand or better understand a certain set of numbers. Well, the first thing we're going to want to do, especially if you want to understand the median, is to arrange them in ascending order. So we're going to label it says 1, 2, 4, 4, 5, 7, and 10. All right. So you can see here that we have 1, 2, 3, 4, 5, 6, 7 numbers, right? And you can see that the only number that repeats itself is 4. So 4 is going to be the mode, and the mode is the number that's going to repeat most often, the number that repeats itself the most. So that's going to be the mode, which is, in this case, is going to be 4. As far as the mean goes, that's going to be the number that is going to basically go, if you're going to basically kind of, a lot of times we think of these as like the average, from there. And actually, yeah, the mean is going to be basically taking up all these numbers and then dividing it by the number of numbers we have. So to be able to identify the mean, all we're simply going to do, and again, I don't have a calculator, so I'm not going to calculate this, and I do want to move on, is we're just going to add up all the numbers. And we're going to divide it by the total number of numbers that we have, in this case, which is 7. To identify the median, we're going to go ahead and find the number that's exactly in the middle. And you can see here we have 3. We have 3. So 4 is going to be in the middle. And if you had two numbers, if it was like an even set, then you just find the mean between those two numbers, which would be adding those two numbers, dividing by 2. But in this case, we have a mean, which is just going to be 4 as well. And the range is basically just going to be the difference from the high to the low. So we'll just take 10 minus 5, and that's going to give us 5 here. So again, by understanding these different parts of information or different pieces of information, we can have a better understanding of what we call the central tendency of this data set, the values that are going to give us, kind of like in that middle range. And you can see already, I didn't calculate what the mean would be, and I guess I could do 6, 10, 15, 20, 27, 28. Oh, so that's going to be, is that 4 as well? Did I do that right? 8, 10, 18, 19, 20. No, that's different. Okay, maybe I did my math wrong. So let's not do that right. Let's just do it. 3, 7, that's going to be 11, 16, 26. No, that's going to be 33, so that's definitely not the same one. Okay, so anyways, I believe that's going to be decimal, so I'm not going to calculate it. I don't think I brought my calculator. No, I didn't. You want to calculate over here? No? Can I bring it over here? Ah, I brought it over here, actually. I do have my nice little handy teacher calculator. So, all right, I'll break my rules and I'll calculate it. So 1 plus 2 plus 4 plus 4 plus 5 plus 7 plus 10, and divided by 7 is going to be 4.7. All right, so I am just going to round that to the nearest tenth, which is going to be 4.7 here. And Polynomial Algebra gives me a super chat. Thank you very much for the super chat. And yes, I do remember you. Thank you very much for the super chat. I do really, really appreciate your loyalty as well as your super chats, and that is why I am making sure that whatever question that you present is I can make sure that I can address it. Even though I can't get to every single question, but I do want to make sure I can obviously get to you. So I do appreciate those super chats. Thank you very much. All right, so, and I believe actually this might have been a question that you might have submitted on the community tab if I'm not mistaken. Check. Perfect. Okay, so let's go and get on to the next one. So natural logarithm, y equals ln of x, overview. I'm not really sure what an overview means. I mean, like I was telling students, like, I mean, I spent a whole class period talking about this, so I'm not sure what justice I can really do with this. The only thing I can really say is, you know, we use the natural logarithms. You know, when we have log base 10, right? Or if we just say like the log y equals log of x, that's really, you know, y equals log base 10 of x. And really, again, what that 10 of x, you know, basically means is like if I have log base 10 of, I don't know, 100, well, that's going to equal 2 because 10 raised to the second power equals 100, right? So converting from that natural logarithm or logarithm of base 10 to an exponential form. So when we're dealing with exponential form, it's just important to understand it's the same really relationship that we're doing over here. It's just y equals log base e of x. So again, if I had like log base e of, I don't know, e squared, well, that's just going to equal 2 because, oh, I'm sorry, that's going to equal, yeah, 2. Because that's basically saying e squared is equal to e to the squared is equal to e squared. Yeah, that's kind of weird. But yeah, that's basically what it is though. E squared is equal to, but all the natural logarithm, all that, we just use that different notation. It's just saying that the base is equal to e. Now, in the same respect, or another thing as far as like the graph goes, you know, if I was to graph y equals log of x, like the logarithm graph looks something like that, and the same thing, y equals ln of x, is going to look the same. Like, yes, it varies a little bit because the base does impact the graph, but as far as the shape of the graph is going to be the same. As well, in the same respect, as far as the transformations and the properties, like the product property, the quotient property, the power property, all those properties are exactly the same if it's a log to base 10, log to base 2, 3, 4, or if it's a log to base e, which we just use that different notation, ln of x. So I'm hoping that helps you out as far as a basic little overview. And then for those of you that are jumping just on this stream, I am just running through these. I believe I have 6 questions, and then I'll hop back into you guys. As far as answer some questions. Yeah, so it's about 4.71 Gibson. Yes, I do believe I say it. I was just abbreviating from there. I didn't use approximate symbols, but yeah, I just made sure I was saying that. Yeah, it's going to be approximate. All right, for question number 3, it says solve the right triangles. So a student asked me to just kind of talk about solving right triangles. I'm not really sure what they wanted from that because there's many different ways how to solve a right triangle based on what type of information you have. So if you have a right triangle and you have 2 sides, then you can use the Pythagorean theorem to figure out what that third side is, right? Which typically we'd call that like C a lot of times. So in this case, we can just do what we call the Pythagorean theorem and so if we call that A and that B, then remember the Pythagorean theorem is A squared plus B squared equals C squared. I keep on forgetting like my camera's over here. So in this case, I would just do 3 squared plus 5 squared equals C squared. And 3 squared is going to be 9 plus 25 equals C squared. That's 34 equals C squared. And then you just take the square root of both sides. So therefore, C equals the square root of 34. And again, just remember, even though a lot of times when we introduce the square root, we're using that plus or minus. In this case, we don't need to refer to the plus or minus because when we're dealing with the hypotenuse, it's always going to be positive, right? The length of a triangle is always going to be positive. So therefore, we can just say C is going to be the square root of 34. Now, if we're only given one side, that is not enough information for us to use the Pythagorean theorem. So therefore, we're going to want to look to our trigonometric functions. Now in this case I didn't say what our missing value was, so let's just say, let's just put C in there again. So in this case, let's say we want to find the hypotenuse, but rather than giving two sides, we're given a side and an angle. So in this case, we're going to want to use our trigonometric function. So basically, we want to look for the sine, the cosine, and the tangent. And remember, those trigonometric functions are just a comparison of two sides of a triangle based on a given angle. So in this case, our angle here is 41 degrees. And based on that 41 degrees, we can see we have the opposite side as well as the hypotenuse. So therefore, we're going to use the sine of 41 degrees equals opposite over the hypotenuse. Now, to solve for this, we're going to have to solve for c. So to do that, we're going to multiply by a c on both sides, and then we're going to divide by a sine of 41 degrees. Let's break it out and want that. C equals the sine of 41 degrees equals 5. That's not supposed to be multiplied. Okay, and then you divide by the sine of 41 degrees. Okay, so therefore C equals 5 over the sine of 41 degrees. Now it's very important when you're evaluating your trigonometric functions to make sure your calculator is in degree mode. So what I decided to do in my class is I made sure that all these problems that we're doing with our calculator is kind of in the same chapter, so therefore I'm not confusing students too much as far as converting between radians and degrees. However, they need to be aware of it because when they get to tests or quizzes or tests and exams, they got to make sure they understand which mode that the problem is going to be in. In this case, we're dealing with degrees, so therefore I'll do 5 divided by the sine of 41. I am in degree mode, so I'm good. Actually, let me just double check one more time. Yeah, I'm good. Okay. So I'll do 5 divided by the sine of 41. And I'm getting 7.62. So again, I'm just going to round that to, let's just round it to the nearest tenth. 7.6. All right, the next one is a graphing. Ooh, a lot of stuff going on here. So how do you graph y equals sine of 3 times x minus pi over 3 plus 2? So there's so many things going on here. Wow. All right, so as far as the teaching goes, I think there's a couple things we need to make sure we know how to do. First, I'll actually explain what I want my students to know, and then I'll go through what I used to teach. I don't teach graphing anymore, but I know some of you guys still do that. So the first thing is I expect everybody to be able to know what the sine of x graph just looks like. So at least what we call the initial period. So that graph is going to look something like that. Okay, so it goes down to -1, up to +1, completes a period in 2 pi, crosses at pi, has a maximum at pi halves, and a minimum at 3 pi halves. I don't know why. 3 pi halves. Okay, so it goes up to 1 and down to -1. So that's what we call the initial period. The next thing is you should understand what the transformations are. So a times sine of, I like to write it like this, b times x minus c plus d. Okay, so we need to understand from here, we need to know what a, b, c, and d are, so therefore we can identify all the transformations. So the first, not so much the transformation, but the information of the graph. So the amplitude is basically the half distance from the max to the min of the graph. A nice way of saying it is like how high does the graph go to how low does it go with no vertical translation. So that's just going to be the absolute value of a. So in this case, that's going to be the absolute value of 2, which is equal to 2. The next one is identifying the period. So the period is going to be how long it takes the graph to repeat itself. So with no transformations, you can see that the graph takes 2 pi for it to repeat itself. But when you have a b, what you're going to do is take 2 pi and divide it by b, or the absolute value of b. Which in this case is 3. So I have 2 pi divided by 3, and that's just going to be my period. The next thing is we want to understand our our horizontal shift, which is going to be our shift inside of the parentheses, as well as our vertical shifts, which could be our shifts outside the parentheses. So in this case, I'm going to have a phase shift, which is going to be pi over 3 to the right. And I'm going to have a vertical translation, which is going to be up 2 units. All right, so basically, if I was going to take this graph, right, the amplitude is kind of the same thing as like a vertical stretch. You're going to stretch it. Instead of it going from -1 to 1, it's going to go from +2 to -2. The period, instead of being at 2 pi, is going to be at 2 pi divided by 3, so you can see that's being compressed. The graph is being shifted pi over 3 to the right, so for you guys, I guess it would be over that way. And then also the whole graph is being shifted up 2 units. So if you look at that graph and you think, wow, that's a lot of transformation, that seems pretty confusing, right? And it is, and that's why I don't really spend as much time going over it anymore because, you know, we mostly are going to have calculators nowadays to be able to do something like this. So this is what I expect my students to be able to understand. However, I used to teach graphing, and when I used to teach graphing, you know, we used to do 2 periods. I'm not going to do 2 periods. I'm just going to take these transformations of the initial period because I don't think it's just a good use of our time to do 2 periods nowadays. So to be able to graph it, there's 3 more pieces of information we need to understand. We need to understand the start, the end, and the x scale. Okay? So the start is where the graph starts. And what transformations, how are the transformations affecting that starting point? So you can see that the sine graph, the initial period starts at 0. So anything that's going to impact the graph is going to be what's inside of the function. Basically our b times x minus c. So basically all we do is take bx minus c equal to 0. And then basically solve for x, and that's going to be the new starting point. So I'll just do 3 times x minus pi thirds equals 0. So you divide by 3 on both sides, add pi over 3, so you can say x equals pi over 3. So now the new starting point is going to be at pi over 3. The end, you can see the graph ends at 2 pi. So again, we're going to do the same thing. So it's bx minus c equals now 2 pi. So I'll do 3 times x minus pi over 3 equals 2 pi. Now in this case, I can't get away with that so easily, so I have x minus pi over 3 equals 2 pi over 3. Add a pi over 3, so x equals 3 pi over 3, which is equal to pi. So now you can see my graph starts at pi over 3 and ends at pi. Now the x scale is how often that graph is going to, like where all these important points are. You can see these important points happen every, in this case, every pi halves, right? So you have either a max, an intercept, a min, and then a max, or an intercept. So to find the x scale, all you're going to do is take the period, and this is only for sine, cosine, cosecant, and secant. Take the period and divide by 4. So our period was 2 pi divided by 3. If I divide that by 4, I think it's divided by 4. Yeah. Divided by 4, then that's going to be, that's the same thing as multiplying it by 1/4, which is going to be 2 pi over 12, which is equal to pi over 6. Okay, so here's what this graph is going to look like. So the graph is going to start at pi over 3. So this is not the x-axis, okay, or the y-axis. This is just going to be at pi over 3. And then basically I'm going to have 4 different points. So I'm going to have pi over 3. Here it's going to be 2 pi over 3. 3 pi over 3, which is just pi. 4 pi over 3. Uh-oh. Wait a minute. What happened here? What did I do wrong? That's not... Oh, pi over 6. I'm an idiot. So the x scale is at pi over 6, right? So if you're going to add pi over 6, it might be helpful to understand this as pi over 6 is 2 pi over 6, right? 2 pi over 6 reduces down to pi over 3. So therefore, this would be 3 pi over 6, which is pi halves. Let's write that down below. So this is 3 pi. I guess I'm covering up myself. Sorry about that. So this is going to be 3 pi over 6. 4 pi over 6. 5 pi over 6, and 6 pi over 6. Okay, so you can see here, those are my points. This reduces actually to pi halves. This is going to be 2 pi over 3. That can remain 5 pi over 6, and then this can be reduced to pi. And then the other point, again, don't assume that this is the y-axis, because if you think about this graph, it has an amplitude of 2, so it goes down to -2 up to +2, and the graph is being shifted down or up 2 more units. So really, this is actually going to be at 0, and now the graph is going to go up to 4. So I'm kind of running out of space here. So I'll just say, so it was at 0, so that's going to be up at 2. So let's say put that at 2, and that's at 4. Okay. Let me get this out of the way. So anyways, goes to 2, graph starts here, max, intercept, minimum, and there. So there you go. That was a long explanation, but graphing is tough, and hopefully at least everything else I covered for you is going to help you out. But yeah, that's a tough problem to kind of get through. All right, last two, and then I'll get into some of your guys' questions. I appreciate you guys holding on with me. All right, f of x equals 2 log of 3x minus 2. So this is really kind of the same question. It's basically asking, like, how do I apply the transformation to logarithms? So again, the same thing. We kind of already talked about this. Like the logarithm graph, the parent function here is going to be here. Like that is what y equals log of x is. So when we have 2, that's just vertically stretching the graph. So that's just that multiplying by 2 on the outside, that is just a vertical stretch. So that's not going to be changing the x-intercept, that's just me stretching the graph. The 3 is going to be a horizontal compression. So whenever you're multiplying outside or inside the graph, that is just stretching a compression. That's actually not changing any of the x-intercepts or y-intercepts. In this case, the graph doesn't have a y-intercept. However, this x-intercept, though, when we have x minus 2, that's shifting the graph 2 units to the right, and this minus 2, which is outside the logarithm, is shifting the graph 2 units down. Now, it's important to remember about the logarithm is there's actually a vertical asymptote there. So if I shift this graph 2 units to the right, I now have a vertical asymptote here. And if my x-intercept was at 1, 0, now my x-intercept is going to be at 3, 0. And then it got shifted 3, and then it gets shifted down 2. So let's go down 2 more units. And then somehow we have to represent this stretch and compression, which, I don't really care as much with my students with that. We spent some time looking at it at the beginning of the year. But besides that, you should just understand that there is a vertical stretch and a horizontal compression. But as far as like graphing it with a logarithm, you could use some extra data points to help you graph it, like an extra graph here or there, but that's about it. Mr. Beast, well, thank you very much for your super chat. I really do appreciate you joining in on some math knowledge here. So thank you so much for that. All right. We got one more question. Literal equations. So in this case, we have literal equations. 3x plus 6y equals 24, and we are going to solve for y. And then we have the area equals 2L plus 3p, and then we're going to solve for p. So the main important thing, just to understand literal equations, like when we're trying to solve a linear equation, we're not trying to solve for really like anything else except for the variable that we are defining. So in this case, in this first example, we're solving for y here. And to go ahead and solve for y, basically what we want to do is isolate it. So we want to undo everything that is happening to the y. So when we look at this y, so there's a couple different ways we can do this, but one way, like when we're looking at this y here, is what we want to do is say, like, all right, what's happening to this y? Well, you can see, obviously, the y is being multiplied by 6, right? But in addition, you can see it's also being added by 3x. Now, it might not be obvious here, but if you were to, like, rearrange these variables, you could say 6y plus 3x equals 24, right? And so you could say, oh, yeah, because that's a positive 3x. So, of course, it's being added to the 6y. So sometimes it might be helpful to, like, understand a problem by rearranging everything. So when you go ahead and rearrange it, we want to undo always addition and subtraction first, and then undo multiplication or division. I guess maybe I can make that a little bit difficult. Let's see. So in this case, we're trying to solve for y, yeah. So to undo, adding by 3x, I'm just going to subtract 3x. Now, again, 24 is a number, and 3x is a variable expression. So they're not like terms, so we can't do anything really here. We're just going to leave it as is. So 6y equals 24 minus 3x. Now, to undo multiplying by 6, we're going to divide by 6. Now again, in this case, the 6 is going to divide evenly into the 24 as well as into -3, but it doesn't divide into -3, so we're just going to simplify that fraction. So again, sometimes, you'll see in these answers, and I think this is where a lot of students will get confused, is like, where does this answer come from? Well, 6 evenly goes into 24. That's going to be 4 times. And then 6 obviously doesn't evenly go into -6, but we can simplify that to give us a negative, let's see, we could write that as x over 2, or we could write this as y equals 4 minus 1/2 x. And then again, obviously, this is kind of one that you would see like in graphing linear equations. So that'd be y equals negative 1/2 x plus 4. All right. All right, let's go to the next one. This was actually kind of like the same. So I'm actually going to change this one up again. You find the y-intercept first by summing in the x. Let's kind of have a little fun. Let's put some parentheses around this one. Yeah, I like it. All right, so in this one it says a is equal, sorry, I keep on forgetting that you guys are down here. So a is equal to 2 times L plus 3p. I keep on looking at my camera that is like right there, and it's so annoying that it's not working, but I do appreciate you guys joining in. I'll get you guys chat. I'll get to a lot of you guys chat here in just a second. So last question, at least that have been pre-submitted. So a equals 2 times L plus 3p. All right, so in this one, what we're going to do is, again, we want to solve for p. But we can't really solve for p in this case, ladies and gentlemen, unless it is not within parentheses. So first thing we got to do is undo the parentheses. And the only reason why we have parentheses in this case is because we have this 2 is being multiplied by both these terms. So there's 2 ways we can get around this. One, we can undo multiplying by 2, which would just be dividing by 2, which would be my preferred method. Or we could actually just distribute that 2, which in this problem would be okay, that would work, but in not all those other problems is that going to be the best method. So, or does it always work for like more advanced problems? But in this case, we just divide by 2. Dividing by 2 is the same thing as multiplying by 1/2, so let's just write that as 1/2 a equals L plus 3p. Now again, same kind of thing. We need to solve for p, so I'm going to subtract an L. 1/2 a minus L equals 3p. In this case, I will divide by 3. Dividing by 3, again, is the same thing as multiplying by 1/3, right? So therefore, I'm going to have 1/6 a minus 1/3 L equals p, and I'm covering myself up. I do apologize. There we go, now I can see myself. So therefore, you can just write that as p equals 1/6 a minus 1/3 L. All right, so there you go, ladies and gentlemen. Our first stream has at least been concluded. I am more than happy, though, to get into your chat. I am only 5 minutes over, which is not as bad compared to some of my other ones. But I do appreciate a lot of you guys that have been joining in. I'm not sure what's going in there. Yeah, I know. I do appreciate it, Jaden. I'm sorry. I'm not sure why this has been a really, really bad live stream for me to be going back at. So I do apologize, but I do appreciate you guys joining in with me on this live stream. There you go. Now everything is back up from there. But everything's not posting. I don't know why it's not posting up from there. It's so weird. Diego, no, you may not use the restroom. I'm watching you, man. Thanks. Benjamin Mariano, hey bud, how are you, man? It's good to have you on the live stream. I'm sorry, my live stream is not working as far as I would wish it'd be going in, but I do appreciate, Ben, you joining in. And next time you have some math questions, make sure that you bring them onto my live stream, and I'll be more than happy to answer your question. But thank you for reminding me who you are. That is appreciated. Ronan Practice says Calc BC is a different ballgame. Yes, for sure it is. I haven't taught Calc BC. I've only taught Calc AB, and but it is like it's the same thing that students take when they go from Algebra 2. When they go from Algebra 2 to Precalculus, a lot of students have like that shock, like, whoa, this is like serious stuff. And it's like the same thing when you're going from pre-calculus, you're like, oh, it's like pre-calculus. It's like, yeah, but it's like you got to take that mental jump as far as that mathematical, like not only just like understanding, but as far as being able to, approaching math differently. It's the thinking process, it's the studying, it's how you work through problems, how you show your work. All that stuff gets stepped up an extra game, and it's not really that much more difficult, but it is something that students have to adapt to, and that is something that is a little bit more difficult for students to do. Mr. Beast, thank you very much for another 99-cent super chat. I really do appreciate it. Now it kind of seems like my things are going on from there. So going through. So I do appreciate. Thank you so much, Mr. Beast. I really do love those super chats. That's awesome. Better mode on your my uncle. That is right, Ben. You got it. All right, Pori. Hey, Pori. K Gaming. Good to see you. Thank you very much, Ben. Any advice for pre-calculus? Yes, Mr. B, since you have given me some super chats, I will definitely do completing the square. I'm not sure if you have an example in mind, but I'll do 2 examples for you. Let's have a little fun. You did spend some extra time for me, so I do appreciate that. All right, so I'll go into that. So Tennis Lover says, any advice for pre-calculus? Well, one of the things I was talking about is this is the same advice that goes for pre-calculus as well as goes for calculus. And that advice is, one is make sure you have the algebra down pat. The biggest difficulty that students have with my pre-calculus class, as well as when I taught, calculus, is the algebra. They struggle with the basics of, fractions, factoring, completing the square, just, the basic graphs, transformation. So a lot of the basic stuff is what students forget, and a lot of it is because, they just learned or remembered the stuff for a certain test, and maybe didn't put as enough practice as they needed to really develop those essential skills as they now get applied more often or more thoroughly in pre-calculus, calculus. So the main thing I would say is, just make sure you feel comfortable with the basics. The next thing is, as far as, some advice for pre-calculus, again, I'm talking up here, and I apologize. I know you guys are right down in there. It's so weird not having my camera up. But the other point is that you guys, that you make sure that that you can adapt, right? I mean, pre-calculus is not algebra 2. You have to make sure that you are learning how to study in a different way. That you're making sure that when you have questions or you don't understand something, that you get help immediately, and that you're not waiting, until the next class period. You need to make sure that you start working through the problems, and I think it might have been in pre-calculus that I started doing extra problems in the book, to make sure that I was really understanding what was, what was going on, or to make sure that I fully understood the content for each lesson. So just a little snippet of advice, and I would say the same thing for calculus as well. Making sure that maybe you do some extra examples for them. Stanley Cam, please do not spam everything. Everybody understands, can you do quadratics for Algebra 1 honors? But I got your message, but I do not appreciate everybody seeing Algebra 2, Algebra 1 honors quadratics for on there. So you suck at math? Well, thank you very much. I really do appreciate you taking the time to come back. And yes, Ben, I'm the best rugby player. That is exactly right. Even though my back feels a little bit better, but yes, it was 4 on there. Well, Anwar, how are you doing? Thank you very much. Yeah, sailing. We don't need. Can you do quadratics for Algebra 1 honors? I haven't taught Algebra 1 honors in years. I do not know what quadratics for Algebra 1 honors means. And so when you keep on just spamming people, that doesn't make anybody want to do a Algebra 1 honors quadratic problem. And again, guys, just to let you know, this is week 1 of the live stream. I'm going a little bit over because I do apologize for my technical difficulties tonight. It's a little annoying not to have everything the way that I want it to be. Okay. Since it is that case, that's why I'm just kind of going a little bit over. And let me see. Sorry, but I do apologize. But I will be going live. My goal, at least again for 2020, is, again, to be continuing going live here every single Sunday night at 9 p.m. Eastern Standard Time. So if you guys do have questions and that you'd like to be added to that, then please feel free to go ahead and submit your questions when I do post on the community chat. And therefore, you can, I will try to answer as many questions as I possibly can get to. Typically, I only go live for roughly around like 30 to 40 minutes, which has been, you got to be going to bed soon, just to let you know, because I have to get off the stream and get myself ready to bed because I have to go back to school tomorrow as well. But I believe, guys, I have hit every question that I need to, or that I'm going to be able to get to. I do apologize. It's just been so weird. I've been like really thrown off my game without not having my camera like right up here and having to like look over here and it not being there. And then I got Sailing Cam, keep on asking me for Algebra 1, quadratics. But Sailing Cam, I'm more than happy to answer your questions. But all I'm going to say is please next time just send in a question that you'd like me to cover, or you can get on my community chat. But I'm just going to end off this live stream with these 3 questions because Mr. Beast has sent in these questions prior to this. So I'll go ahead and get to your super chats for you, Mr. Beast. Thank you very much. And then we'll end off this live stream. All right, so let's do y equals, let's do x squared plus 4x plus 4. Let's do y equals x squared plus 2x. And let's do y equals x squared minus 6x plus 1. All right. Hold on, before I get to that, let's just go ahead and check. I'll go and do these. So for any of you guys that want to know how to do completing the square, I'm going to end off this live stream with doing those. But before I do that, I just got to check one more thing on here. Not sure why this is not working. What's going on? No, that's not it. Featuring Mr. Beast. Maybe on Mr. Beast, I will look into that live stream featuring Mr. Beast. Thank you. First says, my mom is giving me an extra week of school off. I am homeschooled. Well, that's awesome. Take advantage of that while you can. That is good. Again, like, I think there's a lot of schools that like take like 3, even like 4 weeks for you guys to be able to have that. That's, I think that is awesome for you guys. And I think you should, come on, why would I not do that? All right, so I was trying to go and do something, but it's not going to be able to get to this. So anyways, guys, I'll go ahead and get into this last completing the square. And then that'll be it. And then we'll sign off for at least week 1. And that will take us to the end here. So let's go ahead and get into completing the square. Now, the whole point of completing the square is to write a quadratic. Well, not the whole point of writing a quadratic, but one of the points of completing the square is to write a quadratic from standard form, which is ax squared plus bx plus c, into what we call vertex form, which is y equals a times x minus h squared plus k. All right, now don't get confused with the a, b, and c, and h, and k. The main idea I want you to see is that this has like an x squared, and this has what we call a binomial squared, right? It has this quantity x minus h squared. So how do we go from just a variable being squared to a quantity being squared? Well, that is the process of completing the square. All right, so what I'm doing is I kind of work through this progression, and this isn't actually something that I developed, and actually until like this year of teaching. I used to teach completing the square a completely different way, and it was always, the students that got it, and the students that didn't get it. And so I kind of like developed this additional method to really help students that I feel at least kind of helps bridge that gap a little bit. it kind of explains a little bit more, or hopefully allows students to be able to see why we're doing some things we're doing. And actually, I'm going to do one more example from there. Okay. So in this case, we have y equals x squared plus 4x plus 4. Now, if we were just to factor, forget completing the square, let's just factor this. If we were to factor this, we're asking ourselves, what two numbers multiply to give you 4, add to give you 4? Well, that's going to be x plus 2 times x plus 2. Well, when you have x plus 2 times x plus 2, you can just rewrite that as x plus 2 squared, right? And you can see what we just did here by factoring. We actually rewrote this as a vertex form, right? We went from standard form to vertex form. We wrote this as what we call a binomial squared. This is a quantity raised to the second power. So the reason why completing the square works is because when we have what we call a perfect square trinomial, all perfect square trinomials can be written as binomial squared, or they can be factored as binomial squared. So our goal when we're completing the square is to create perfect square trinomials. So I don't know why I did everything in black. That's kind of weird. So what I'm going to do here is when I'm working on these problems, I'm going to want to create, my goal here is to create perfect square trinomials. So in this case, I have an x squared plus 2x. Well, again, what I'm basically asking myself is what number should I add here that would make this a perfect square trinomial, right? What number would I add that when I multiply, the same two numbers are going to multiply to give me a number, they're going to add to give me 2. And sometimes that's a little confusing for people to say out loud. But when you get a little bit of experience here, you can see that that number is going to be 1, right? Because 1 times 1 is 1. 1 plus 1 is 2. Now we have created a perfect square trinomial, which is x plus 1 squared. Okay. However, you just can't add 1 to an equation, right? You just can't add 1 and say, hey, I got a perfect square trinomial. If you're going to add 1 to an equation, you also have to make sure you subtract 1. Now, we only want the binomial squared, though, or this perfect square trinomial to create the binomial squared. So we're going to keep that in our parentheses, but we're going to keep this minus 1. And again, that's okay. That's going to be our k. So that is going to be a part of our vertex form. But just remember, an equation is equal on both sides, right? So it's either you add a 1 to both sides, or you add and subtract on the same side. So where it gets a little confusing, where we don't really do these problems, and this is where I kind of went to teaching, or what I started doing is including more of these two problems. Because I never really did these with completing square. We just immediately would jump to a problem like this, which is, let's create a perfect square trinomial from here. Well, in this case, if we want to create a perfect square trinomial, we don't really need the 1, right? Because we know that 1 times 1, gives you 1, but that doesn't add to give you 6. So what we're going to do is we're going to say, well, let's just group the first two terms and say, what can I add? Like, what perfect square trinomial would this be? Now, when you get experience, you would see that that number is going to be 9. Okay, because 3 times 3, or negative 3 times negative 3 is positive 9. Negative 3 plus negative 3 is negative 6. But again, remember, you can't add 9 without subtracting 9, and then plus 1. And actually, for tile, I'm not going to do let's just keep it there. Boom. Okay, and now you can see that we created this perfect square trinomial, which is going to be an x minus 3 squared. Negative 9 plus 1 is going to be a negative 8. Now, a lot of people are like, well, how are you always going to be remembering like those perfect square trinomials? It gets kind of a little confusing there. So that's where the b divided by 2 kind of comes from squared. All right, so if you want to be able to figure out what that value is that adds, all you got to do is take b, which is your middle term in your quadratic, divide it by 2, and then square it. And that's always going to give you that term. So for instance, negative 6 divided by 2 is negative 3. Negative 3 squared is 9. Boom. In this case, 2. 2 divided by 2 is 1. 1 squared is 1. In this case, 4. 4 divided by 2 is 2. 2 squared is 4. So when you want to create that perfect square trinomial, all you got to do is take the middle term, divided by 2, and square it. But my goal is that you'll be able to, again, with some practice, be able to start doing these without having to rely on the b divided by 2 squared, but you can start identifying those perfect square trinomials. However, this is helpful when you don't recognize a perfect square trinomial or when you have fractions and so on and so forth. So I lost track of my chat. I guess I did. Jeez. Either way. I guess it doesn't want to. No, it's that. All right, guys. Well, either way, I do apologize for those of you guys that joined on late. I do want to let you know, though, that this is the first live stream of the year, and I do plan on going live every single Sunday at 9 p.m. Eastern Standard Time here on the channel. And then hopefully next time I will have my camera set up, so therefore I can do a direct-to-camera, not using my laptop cam here, which I'm not sure why things are going, but I was out of town today, and I just got my studio to set up, some new things going on, and it did not work out. But I do appreciate you guys showing up for my live stream tonight, and I do wish you guys a great start back at school for those of you that are heading back to school this week or maybe the week after. And I look forward to answering your questions on the upcoming stream. So you guys have a great one, and good night. Cheers.